session. Friends, today in this video I will talk about how to design a power factor panel. So power factor correction panel is used to correct the power factor. So friends, we will assume some settings. Suppose first of all, friends, you must know what is your power factor without power factor correction panel, and what is your total load. So these things you must know before calculating the power factor. So friends, first of all, suppose our total load is P is equal to 223 kilowatt, and the next you must know that what is your current power factor without power factor correction. So suppose our current power factor is 0.80. So friends, the current power factor will be denoted by cos phi 1. So the cos phi 1 will be, so our cos phi 1 will be 0.80. And now you must know that what is your target power factor, till what value would you like to increase your power factor. So suppose I would like to increase my power factor from 8.80 to 0.98. So my target power factor, or cos phi, my target power factor is equal to 0.98. So friends, the target cos phi will be denoted by cos phi 2 is equal to 0.98. So we will use 8 as a phi, so you will know that when we are calculating. So friends, now the formula for power factor correction is, we will calculate it in kvar, how much kvar are you required to install in your circuit. So total kvar required is equal to P into cos phi 1 minus cos phi 2. So friend, this is the formula we will calculate. Sorry friends, this is the not cos, it's a tangent. Tangent 1 minus tangent 2. So the next, friends, first of all we need to find out the tangent 1 and tangent 2. So we know that cos phi 1 is 0.80 and cos phi 2 is 0.98. So we will find out first of all tangent. So tangent will be equal to cos phi. First of all, friends, we need to find out the value of phi. So phi will be inverse. So phi 1 will be cos inverse of 0.980, inverse of 0.80. So friends, let's calculate that cos phi 1 will be, so you have to take the inverse of 0.80. So calculate 0.80, take the inverse cosine inverse. It's friends 36.86. So this is the phi 1, and phi 2 will be equal to, so it will be cos inverse phi 2 0.8. So we will take the inverse of 0.98. So let's see, take the inverse of 0.98. So friends, we will take the calculator. So 0.98 inverse, take the cos inverse of cos. So it's friends 11.47. So it will be 11.47. So now friends, we know the values of phi 1 and phi 2. We will put it here in tangent phi. We will put instead of phi the values of phi 1 and phi 2. So friends, required kvar is equal to power into tangent. Put the value of phi 1. So the value of phi 1 is, phi 1 is 36.86 minus the value of tangent phi. Put the value of tangent phi 2. Put the value of phi 2 is 11.47. Close bracket. Go to the next. So friends, we have to take the tangent of 36.86. So let's go to the calculator. So the 36.86 tangent, the value is 0.749. So required kvar is equal to P into, put the value of tangent 3.86, which is 3636.86 tangent. So 0.7497, 0.7497. So let's take the tangent of 11.47. So 11.47 tangent, it's 0.2029 minus 0.2029. Close the bracket. So friends, required kvar will be the required kvar is equal to power into minus 0.202. So we have to minus point so friends, minus 0.7497 minus 0.2029 is equal to 0.5468. So the value is 0.5468. Close the bracket. So the required power factor, the required kvar will be, our total power is 223 kilowatt into 0.5468. So multiply, we have to multiply into 223. It's 121.93 kvar. So friends, this is how you can calculate the kvar to increase your power factor to the target value. So the required kvar, so friends, the required kVA is equal to 121.93 kVAR. So friends, if you would like to increase your power factor from 0.80 to your target value 0.98 and your total load is 223 kVAR, so you must add 121.93 kVAR in your circuit. So friends, thank you for watching. I hope you will be able to calculate your kVAR. If there is anything, you can mention in the comment and I will be able to answer your questions. Thank you for watching. See you in the next video.